All right, so today we're gonna get started with a little warm up. All right. Actually, well, let's see. Today's lesson is like just a bunch of number evaluation. So your basic operations: add, subtract, multiply, divide. Learn about I can't talk. Sorry. Common factors, greatest common factor and least common multiple, and negative numbers, absolute value, all that stuff. You guys should know all this stuff. So just easy review today. All right, a little warm up. So Alfred wants to sell all his apples that he picked from his farm. He has 600 apples in total and 4 baskets to sell them in. If he wants an equal amount of apples in each basket, how many apples are in each basket? And number 2, a bullet train can travel about 3.33 kilometers per minute. How many kilometers can a bullet train travel in 1 hour? So I'll give you guys a few minutes. That one up. You cannot split the apples. It's not good business if you do that, you know? It will not be good business. Why is tomorrow a good day for me? Well, I hope I won't be distracting you from doing your warm up, but tomorrow is TSM versus C9. Yeah, that's the right answer, Max. Tomorrow is TSM versus C9. And if TSM wins this, they can go to Worlds. But C9 is a tough team to win against. I don't even know if he knows what this means, but C9 is a tough team. And we'll see if TSM can win it. It's a best out of 5. So that's why tomorrow is an exciting day for me. If TSM loses tomorrow, then whatever. That's whatever. Yep, that's right, Cindy. Yep, that's right, Zoe. Oh, there's 2 Zoes. Zoe without the Y. So this one, pretty simple. Just a array. This one's a unit conversion. Also pretty simple. Yep. I may have typed the wrong answer. I don't know.
Throwing it away.
All right, not everybody. We're doing this warm up right now.
你拿走可以吗？你讲话的功夫都已经拿走了。
I'm trying to remove it.
你帮人家拿一个勺子。
Sure, I got you. That should be better. Yep, that's right, Joseph. Yep. Yeah, pretty easy. Just a little warm up. No, Zoe, without a Y. That is a really, really big number. Yes, that's right, Berlin. That's a really big, just make sure you get your right units. Because 100, I can't say the answer, but number 2, make sure you have units in it. Because I don't know. Yeah, but make sure you got units. You're close, Catherine. You're missing 1 unit. Actually, no, never mind. You're fine. You're good. Never mind. I didn't see it. Yep, that's what you do, Zoe. Without a Y, without the Y. There's 2 Zoes here. That's gonna be interesting. Wrong units, Fairwind, but you have the right idea. Right idea. It is not miles. It is. What is it? There you go. Nice. Okay. Alrighty. Yeah, there you go. Okay. All right. See, I think I'm getting a couple more answers in. It's not everyone though. Okay. So let's move on. Pretty good. So yeah, 600 apples divided by 4 baskets is 150 apples per basket. This should have a per basket. If you want to be really precise, per basket, because the unit's right here. So there's 150 apples in each basket. And this would be y per a slash. Well, because the unit's right here. Because if you treat these as like a unit, like if you treat this as like a unit, then you would still keep it there, right? So like, say this was, no, the apples per basket. That's just how it is. It's just, if you treat it as a unit, you have to keep the units. That's just how it works. Oh, but slashes divide. Yeah, slashes divide. Yeah, slashes they divide. 150 apples per basket. Okay, and then number 2 is just simply unit conversion. The minutes out here cancel because this is on the denominator and this is on the numerator right here. So they both cancel. And so you're left with 199.8 kilometers per hour. So you can travel 199.8 kilometers in 1 hour. And to put that in perspective, bullet trains are super duper fast. They can travel, that's about 124 miles, or a third of the distance from Sacramento, California to LA, California. Now, if you don't live in California, I will tell you, a car ride to, so do we, I don't know what that means, Lisa, without why. You're gonna have to rephrase your question. But to put that into perspective, if you ever lived in California and you driven from Sacramento to LA, it takes about like 7 hours, including traffic. Yeah, that's why they call bullet trains. Yeah, because fast is like a bullet. So imagine getting to LA in 3 hours as a person who's from Sacramento. I'm from Sacramento. I would love to go to LA in 3 hours and not in 6 to 8 hours because traffic and car rides are annoying and all that jazz. How do we know which one the slash is meaning? Okay, so, oh, this just means cancel. I guess I should do a straight line. This just means canceling units, but whenever you see a slash, always assume it's division or a fraction. So if you see, I mean it's the same thing because if you see 5/6, that means 5/6, right? But it also means 6 divided by 5, 5 divided by 6, all right? 5 divided by 6. This should be 6, 5. So you should know that. If I'm not so sure if that's what your question is, but yeah, like I said, PowerPoint doesn't like me typing this stuff out. So yeah, all right, move on. Negative numbers, you guys know all about negative numbers. All right, negative numbers are values meaning less than 0. Well, there you go, whoop-de-doo. Everyone knows that, and it's shown by the minus sign. Positive numbers, obviously, are values meaning more than 0, shown by a plus sign. Typical number line like the one shown below, you'll see in a second, you would have all values counting up from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in between is all the decimals. So 0.1, 0.01, 0.0001. So there's an infinite amount of numbers in between 0 and 1. And same thing for 1 to 2 and 2 to 3. So it's all the decimals, all the fractions. Likewise, 3/4 would probably go somewhere here, 1/2 somewhere right here, 3/2 go somewhere right here. Why? What do you mean why? Well, if you split this in, you can split this into little segments. So you can infinitely split into equal segments because you can just keep creating more and more numbers in between because you can just add more zeros decimals. Why are there infinite decimals? Because that's just how it is. There's infinite numbers. 0, 1, 0.01. You can have 0.11. These are all different. There's already 3 different numbers and you can keep going. Okay. Okay. So, yep. That is, hope you answered your question. That is the wrong thing. Pen. Thank you. So once we go anywhere left of 0, we become negative. So -1, -2, -3, etc. shown below. So right here, see anything left of 0 is -1, -2, -3, -4. You guys know this. You guys should know this already. I learned this in 3rd grade, 4th grade maybe. And obviously you guys know that number lines can also be vertical. So we have 0 here. Anything below 0 is negative. Anything above is positive. So, yeah, my camera is still not working. I don't know why. I think it's a Windows 10 thing because I looked it up on Google and it's known to have problems with Windows 10, but I thought it wouldn't be a big deal because people said they solved it by downloading the right drivers. But that's besides the point. But yeah, my camera is still not working. Okay. So as an example, using the number line below, put a dot where -5, 3, 2.5, -2 and 1/4, and -0.5 are. Now, obviously, you guys can't do it, so I'll do it with you guys. So -5, well, it's pretty obvious. You can see a -5 right here. So just count 5 units left from 0, and you put -5 right here. 3, same thing. Just count, you see the 3 right there, count 3 units to the right of 0 because it's +3. Now, notice you don't have to have the plus right here, but you could. Obviously, the numbers that you've been dealing with all your life don't have the plus and they mean positive. So, yep. So you put the dot right here, 3 units to the right. 2.5, well, that would be in between 2 and 3, right? Because it's a decimal. This is 2 and 1/2. And so you look for 2 and I kind of eyeball it right here. I guess 1/2 is about right here, maybe a little bit more to the right, but just add a dot right there. -2 1/4, same thing. So it'd be between -2 and -3. And if this is 1/2, then a half of a half, which is a quarter, which is what this is, would be about right here. Eyeball that. Are negative powers real? Yes, negative powers are real. That will be tomorrow's lesson though. Yes, negative powers are real. Okay. And -0.5, same thing, just half between 0 and -1. Eyeball it, put one right here. Easy enough, easy enough. You guys know all this. All right, why do we need negative numbers? You guys know why we need negative numbers. It's not that bad. Negative powers aren't that bad. All right, we use negative numbers to express a lot of things. A few examples: debt. Obviously, when you owe money to someone, you have negative money. Now, if you're working for a negative wage, I think you might want to renegotiate that because I think you're paying someone to work. That wouldn't make sense. So keep that in mind. Temperature, obviously, when it's really cold, you can go to negative degrees. So I think the coldest temperature is negative. Ooh. Well, that's absolute 0. Never mind. That's a totally different conversation. No, 0 kelvins is not possible. No, that is absolute 0. That is not possible. Energetically, scientifically, it's not possible. That's besides the point, but that is scientifically impossible. We've tried. We've gone really, really close with super duper small particles. We've gone to 0 kelvins. So 0 kelvins is a different scale for temperature. It doesn't have any negative numbers. So you know Celsius. So there's degrees Celsius. We use degrees Fahrenheit in the US. Degrees Celsius is everywhere else. And there's kelvins, just K. There's no degrees. Why can't you? It's not energetically favorable. I'm not going to teach you guys like thermodynamics and energy and all that right now. This is a math class. Yeah, that's super cold. But at that point, it's with a super duper small particle at that point, so you don't even feel it. What do you mean by favorable? Okay, now that's I had to get into thermodynamics. Okay, so how states of matter work, right? There's a reason why states of matter exist. The reason why is because their energy, the energy that they have currently, they want to have it to the lowest degree of potential energy, right? Because think about it, if you teleport a ball in the middle of the air, it's gonna fall down, right? Because the ball doesn't like to be in the middle of the air, like somewhere high up, right? It wants to go down because gravity is forcing it, and the energy from gravity makes it favorable that it goes all the way down to the floor where there's no other forces acting on it. There's not getting enough energy, right? Kind of the same thing for absolute 0. When you have solid state of matter, technically, okay, it's super off topic, but I guess you guys are super curious. A solid state of matter technically is still moving. Okay, you don't see it obviously because the atoms. If you know what atoms are, then good for you. You don't see it like this really, really small particles, right? Yeah, tiny. Is negative 2,763 degrees possible? Which degrees though? Fahrenheit or Celsius? I'm sure it is. Well, actually, I don't know about Celsius, but I'm sure Fahrenheit is. But in a state of matter, a solid is actually technically vibrating. So temperatures are moving. Temperatures are not moving. No. Solids are moving. The atoms in the solid are technically still vibrating ever so slightly, right? So that's why we can't reach absolute zero. We cannot make them stop moving. That would just ruin the entire space-time continuum of solids and stuff, okay? I'm not gonna get into it, guys. This is not a physics/chemistry class, okay? Can't get there. Can't. I had to restart this entire course and add like another year to this. Okay. Okay, so obviously negative, you're missing a value or you need a value. You would have a negative amount of that value. I'll say the cliche thing when you're older. You'll know when you're older, okay? You'll know when you're older. And that's anything related to loss or losing something, you will probably have a negative value. You will know when you're older. It's good that you guys are curious. That's good. All right, numerical opposites. This is really easy. Okay, so the opposite of a number is the number on the other side of zero, the number line, and the same distance from zero, right? Now that gets an absolute value a little bit, same distance from zero. So example, -4 is that should say numerical opposite, but same thing, opposite, numerical opposite, same thing. -4 is the numerical opposite of +4. So on this number 9, see -4 right here. It's 4 units away from 0. 1, 2, 3, 4. So there's -4. And the opposite would be 4 units also away from 0, but to the opposite side. So 1, 2, 3, 4. Right. Why would I say that? I thought that was a question. Okay, so easy enough. Do I mean reciprocal? No. It's called numerical opposite. It's literally just the opposite. -4, opposite 4. Opposite of -5 is 5. Opposite of 0 is 0. Okay, you should know that. Okay, yep. Opposite of x is -x. That should have negative. Opposite of y, -y. Opposite of -z is z. So opposite, you just flip the sign basically. Not flip the sign, you just add the negative or remove it. Okay. Comparing and ordering negative numbers. I'm gonna pretend I'm not saying this, Jenny. Does 0 have an opposite? No. So -0 is special. Okay. -0 is equal to 0, which is equal to +0, because they're all technically the same thing. It's all 0. So technically yes, technically no. Neutral, yeah. It's a little special. Okay. So when you compare negative numbers with each other, you should know how to do this as well. Or positive numbers, you know that the further right it is on the number line means it's greater. And likewise, the further left it is on the number line means it's lesser than a certain number. I think I talked about magnitude here. Okay, another thing to know with negative numbers, the bigger the negative number, so that the magnitude of the negative number, the more less it is. So -12 is less than -3. Everyone, you guys should know that. What does lesser mean? Just lesser, like less. Like this is less, it's smaller, you know? So example, compare -4 and -16. Which number is greater? Class. Should be really obvious. Yeah. Yeah, okay. I don't need more answers. -4. So if you imagine a number line, you see that -4 is further to the right of -16. So, yep. Correct grammar. We're kind of gonna say, yeah, well, maybe people might not know. Correct grammar, what do you mean? So -50 is big? In what context? It's okay, the magnitude is large. The magnitude of -50 is large, but if you compare -50 with like -10, it's smaller than -10. Okay, so the bigger the number, the negative number is, the smaller, the less it is. I don't want to say smaller then, because then that doesn't make sense. You never heard the word before? What word? The word lesser? You've never heard of lesser before? Wow. Nope. Oh, well, there you go. And last thing, notes. Obviously, you already know this. I already said this. I'm just reiterating myself. Negative numbers are always less than 0. Okay, negative numbers are always less than 0. And positive numbers are always greater, Okay, you can't be equal to 0. You cannot be equal or less than. So if this was a negative number, this does not work. This does not work. You can't do that. You have to be less than. But 0 equals 0. That is true. Lesser than. That is true. 0 does equal 0. Okay. An example, a little example to keep you guys occupied. List the following numbers from least to greatest. So we have 7/3. I'll rewrite this as fractions. 7/3, negative 5 halves, 2, negative 1.75, negative 2.25, 0, 14, negative 12/3, which you can simplify instantly. I'll leave you guys to it. Yeah, I just said that, Jenny. Yeah. Positive 0, 0, negative 0 is equals to 0. Yeah. So I can give you guys a little bit to do that. Yeah, I don't know how else to explain that we can't get to absolute 0 with basic knowledge. Because I have to get into laws of thermodynamics and all that, and that would not be. Do your work. Yep, that is what I have. Nice job, Sophie. Let's see, Fairwind. You don't seem to have any negatives in that. Check the numbers again and list them with the negatives. Because if they were positive, all positive, then yeah, that would be right. But yep. How do negatives get simplified? You could treat it as the same. So this simplifies to -4. It's the same thing because if you looked at positive 12/3 equals 4, this one you just add the negative sign. It's a 5/2. See. Yeah, I think that's right. Yep, that's right. Yeah, I think you guys got this mostly right in the bag. Yep. Okay, I'm seeing your answer in chunks, Joseph, but I think you're getting there. Yeah, I think you're right. Yep. Let me check your other chunk. Yep. At the first you saw negative 12 thirds was negative 12 over 13. I'm sorry. You try writing with a mouse. I mean, you can see it right here. It's in text, plain text. Not quite, Fairwind. Remember, the bigger the negative number is, the bigger magnitude, the smaller it is, the lesser it is. So it's least. That's not a word, but it's more least. That's also not correct grammar. But hey. But I think you're getting there. You have the right idea, sort of. Haha, very funny. I try. That's not funny. That was not funny. That was not. I wasn't trying to be funny, but hey. Unless that was sarcasm, which hats off to you. You're being sarcastic. I am a person. We all make mistakes. Yeah. I guess. I mean, that's nice. Nice spelling on those words. So, I think that was on purpose. I don't know. Was that on purpose? Let's see. I see what you did there again. Yep, that is right, Max. Let's see. I have a feeling I didn't check anyone. Just yeah. That should be right today. I think you left out the -5/2, but that's fine. Oh, you thought it was positive. I see. Okay, but yeah, you have the right idea. How long is class? Until 6. We're about halfway done. All right. Oh, 9. Yeah. Okay. 9. East Coast. Yes. Or wherever you guys are. It ends in 30 minutes. Okay. There. Keep forgetting. It ends in 30 minutes. Fairwind, no, but I think you're getting there. Let's see. Okay. So -12 thirds is 4. And -5/2 is 2.5. -2.5. So those would be the least too. So yeah. Come on. Well, I gotta keep the class moving. So here's your answer. I didn't simplify them, obviously, but you can simplify them. Why is there 2 2s? Why is there 2? Whoops. Okay, don't cross that one out. No. The second 2 should be gone. Back. Okay. So here's your, yeah, see, so this is -4. This is -2.5 and -2.25. Yeah, I have no idea, whatever. So notice how it's a bigger number, but since it's negative, it means it's lesser. That's what I mean. The bigger the magnitude, the bigger the size of the number, the lesser it is. This is for negatives though. If it's for positive, if this was positive, then it would be 2.25 is least, then 2.5, and then 4. My handwriting is bad, I know. I'm rushing. Yes, that is right. Zoe with a Y. Yes. There's 2 Zoes. So yeah. All right, moving on. Negative symbol as opposite. All right. So if you saw this number, the opposite of opposite 15 or negative 15, what do you think this number is equal? You guys should know this. Of course, I am rushing. Yes. Yes, sir, and or ma'am. Yes, sir. 15. Yeah, there you go. Positive 15. Let's work this out. So negative 15, opposite 15, means 15 units to the left of 0, right? But then you do the opposite of opposite. When did class start? I need to know because we're saying on that class for 45 minutes. Class started at 5. or 30 minutes ago, 32 minutes ago, not 5. A minus is positive. Yes, you guys should know that. So then the second, this part, the second minus tells us the opposite of whatever comes next. So the opposite of the opposite is just the number itself, right? So if you it's like ping ponging back. So you first go left 15, right? Then you go back to 15, positive 15, because the opposite right here. Yes, I know you're in 4th grade, Jenny. You've told me many times. So this means we're trying to find opposite of the opposite, which means we go back to the right, because negative 15 starts to the left. Then opposite of that ends up at the right. So you're kind of ping ponging back. So negative 15 is actually just positive 15, which is also true. Because this technically means 1 times negative 1 times negative 1 times 15. That's what this means. That's what this technically means. That's how you write negative numbers. I proved him wrong. Good job. Proved me wrong? I don't know. So yeah, it's a little hard. Just know that an opposite of an opposite is positive. So if you have 2 negatives, equals positive. If you have 3 negatives, if an odd number of negatives, it's negative. Even number of negatives, it's not me and your brother. Okay, it is. So if it's odd number of negatives, it's negative. Even number of negatives is positive. You guys should know that. All right. Which of the following statements are true? So based on this number line, you're saying, does A equal negative A? Actually, this is technically independent, but I kind of need to zoom through, but hey. A does not obviously equal negative A because that wouldn't make sense. A does not equal the opposite of itself. So 1 is not true. Yeah. E equals negative A. Now that's true because notice how, so if I mark this out, 1, 2, 3, this is 1, 2, 3. A is 3 units away from 0, and E is also 3 units away from 0. So the same distance away from 0, but they're on the opposite sides of 0. So this is true. B is equal to D, same thing. They're both 1 unit away from 0, opposite sides. So this is true. Negative B equals D. I mean, B does not equal D. Negative B equals D. No, sorry. Yes, I'm rushing, guys. Yes, negative B equals D, yes. Because if B went over here, then they would be on the same spot. Same thing, B equals negative D. D was over here. B would end up, B and D would be the same spot. Negative C equals 0. That is indeed true. This is a terrible exercise, by the way. I got this from Khan Academy. I don't know why they made you do this. Obviously, negative C equals 0. Yeah. So 0 equals 0 all the time. And there's 3 opposites, 3 negatives. So negative B is equal to D, which is true because we proved it in this one. There you go. 2, 4, 5, 6, 7, 8 are all true, and only 1 and 3 are false. I think if you learn absolute value first, absolute value is down a couple slides. Maybe that would have been easier. All right. Absolute value. So absolute value simply means the distance from 0. And it's denoted by 2 vertical lines, is denoted by 2 vertical lines like that. So like that. X is any number. So example, absolute value 5 looks like this. Is 0 positive or negative or none? That's a good question, actually. I think it's none. It's neutral. Yeah. I mean, you could say negative 0. That makes no sense, but it's the same thing as just saying 0. So yes. None. Yeah, it should be neutral. Should be none. Okay, you can also take the absolute value of a negative number, which would just give you the positive number. So absolute value of negative 5 is this. So that being said, absolute value of 5 is 5, right? And the absolute value of negative 5 is also 5. Yeah, 0 goes absolute value 0. Yeah, 0 units away from 0. I think it is that. Well, since absolute value means the distance from 0, answer to both would be just be 5. 5. So if you don't want to memorize what the formal definition is, just know that anything in absolute value becomes positive. Okay. Now anything outside of it might affect it though. So this is because on a number line, both units takes 5 units to get to 5, and negative 5 means that distance from 0 is just both 5. So there you go. Absolute value of 5 is 5. Absolute value of negative 5 is 5. And like I said, if you don't memorize this definition, simply means the distance from 0, then just know that it makes everything within the absolute value positive. So you see that? Both 5 units away from 0. And there you go. All right. have some practice. I give you guys 3 minutes to do this. Should be really fast. How did you get 17.5? Never mind, you made up the last one. Never mind. I think you're 1-0 too much. 1-0 too much, Zoe. Zoe without a Y. 1-0 too much. Oh, your numbers would not have an absolute value denotation. 4 does not equal to, I'm joking, Katha, I know what you mean. So this number 5 will have 4 different answers because you just plug it in for each value of x. What does number 5 mean? So just say find the absolute value of x if x were equal to these 4 values. I'm going to cover them up. But find the absolute value of x if it equals one of these 4 values. So your answer would have 4 answers, sorry. So just plug it in one at a time. And then you would get 4 separate answers. Yeah, Catherine's got it. That's what it means. I guess I get to algebra next week, I think. If you don't know what that means, you just plug it in. Yeah. So like, for example, so first answer would be 5. I'll give you the answer for number 5. Next, second answer would be 3.5. Third answer, sorry, would be positive 1.39. And your last answer would be 7. There's 4 different answers because there's 4 different values for x that are possible. Yep. Yep. All right, let's move on. So here are the answers. Notice how this is -10 because the negative is on the outside of the absolute value. So this technically means, I don't like this. This technically means -1 times 10. Because the absolute value of -10 is just 10. -1 times 10 is -10. Yep. That's the formal definition of negative means. I have a different computer, second computer. So I can, just in case something happens on this one, I might be able to go back to the other one. So yeah. All right, pretty good, right? Any questions? No? Yeah, this is pretty straightforward. All right, integers. I think you guys know what integers are. Integers are numbers that can be written without any fractional component. So integers are whole numbers, and they can also be negative numbers. You guys know what integers are, yeah? 0 is also an integer because there's no fractional component. That is doomed. Don't do that. This is doomed. Don't do that. 0 divided by 1 though is fine, but don't do this. Don't do that. Okay. So examples of integers: 0, -2048, 12, 1, -2, 3 plus 5 because you can simplify that to 8. That's also an integer. -2 plus 3 because you can simplify that to 1, +1. And examples of non-integers, well, any decimals: 9.75, 5/4 because that's a fraction, -0.5, and pi, the approximate value of pi. Are fractions integers? No. Anything can be written without any fractional component. That is an integer. So basically they're whole numbers, but the negative numbers are technically not whole numbers because the way school system teach you. So they're counting numbers like 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3. That's where integers are. Rational numbers. Okay. I think I should tell you guys this real fast. So operations with negative numbers, because we are not even close to being done. Operations with negative numbers. So you guys know that if you multiply two negative numbers, you get a positive number. If you multiply a negative number by a positive number, you get a negative number. Really fast notes. If you divide a positive number by a negative number, you get a negative number or negative quotient. If you, same thing, if the negative was on the numerator, you would also get a negative quotient. Triangle. What? So you guys should know this. Negative times negative is positive. Negative times positive is negative. You can rewrite addition all in terms of subtraction. So if I have a plus b plus c, right? Okay, I have a, b, c, not a plus b plus c. If I had a, b, c, right? And at a minus b minus c, you can rewrite this all in terms of addition. This because this is the same thing as a plus negative b plus negative c. That's what these two are the same thing, right? And you can also write addition. So if you had a plus b plus c, you can write that as terms of the subtraction as a minus negative b minus negative c. And notice that when you have two negatives together, when you're subtracting a negative, you basically add the number. So these two are the same things. These two are the same things right here. So just a quick rundown. It helps you visualize when you are adding and subtracting negative numbers, which I don't think I had made as part of this lesson. So yeah, quick visualization. Okay. Rational numbers. Assume this quick. A rational number is any number that can be written in the form a divided by b, where a and b are integers, so non-fractional numbers, and b does not equal 0 because you cannot divide by b. Okay, you just can't. Just don't ask me why. I'm joking. I will be. I mean, if you ask me why, I'll tell you, but not right now. So integers, fractions, and terminating and repeating decimals are all rational numbers. That might have an exception though, maybe. So 2.5, 7.5, or 7 over 5, 0.25, which is a terminating decimal, which can be written as 1/4, and 0.3333, which is a repeating decimal, because it can be written as 3, one line, or 1/3. Opposite of rational numbers are irrational numbers, so they can't be written as a simple ratio. Non-terminating decimals are the most common irrational numbers that you will find on this planet. Example, pi, which is never ending. Yeah, like pi. E, which is Euler's constant, which is the limit as n goes to infinity, 1 plus 1 over n to the n power. You don't need to know that, but that is Euler's number, or Euler's constant is E, and square root of 2, which I don't think you guys learned square root. I didn't teach you guys about square roots and stuff, but I teach you guys about exponents next lesson. And infinity. Infinity is, yes, infinity is irrational, yes. So E, pi, and root 2 are examples. So practice. Are these numbers rational or irrational? Well, number one, you should see straight off the bat is completely rational because it's a over b. These two are integers, 78 and 4 integer. Pi square is completely irrational because pi is irrational in the first place. Yep. No. No. What do you mean no? What? Okay, e plus 1. Well, if e is already irrational, you're just adding 1 to it, it's still going to be irrational because the decimal is technically never terminating for e. This can be written as 2/3. So this is rational. Infinity plus 1, that's also irrational, right? I mean, that breaks the taste. Yeah, you get that. E to the I pi equals -1. Okay, obviously you don't need to know this. I is special too, but -1 itself is a rational number. So technically this part is rational. This part is irrational though. What is E? E is Euler's number, or Euler's constant, sorry. This is E. It's approximately 2.718281824, blah, 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 blah. Keeps going. And the formal definition of this is the limit as n goes to infinity of 1 plus 1 over n to the nth power. You don't need to know what this means. This is high school stuff. Don't worry. Okay. So there you go. So the left side is technically not rational for e to the I pi, but the right side is. So e to the I pi equals 1 plus 0i, which yes, it is, or it should be -1, which is -1 because the 0 times anything, but then this is, the 0i is special. So it makes it irrational. Okay. Common factors in GCF. I'm going to zoom through this real fast. I think you guys should know how to do this. So a factor of a number C, a factor is if number A times number B equals C. So basically A times B is C. A and B are factors. Yeah, I'm going to zoom this fast. So in other words, factors are numbers we can multiply together in order to get to another number. Number can have many, many factors, and all integers have one in itself as factors. For example, factors of 2 are 1 and 2 because 1 times 2 and 2 times 1 both equals 2. So they're both factors. And also 2 is prime. We'll get into prime numbers later, prime factorization, a couple slides down. And note that same negative numbers are also factors. So -2 times -1 is also 2 because negative times negative is positive. But usually we don't list negative numbers as factors though. So a common factor between 2 or more numbers, it's a common factor when it's a factor of 2 or more. So when they share factors, basically, this is a horrible definition. What am I typing? When 2 or more numbers share factors, they're common factors. And the greatest common factor is the biggest common factor between 2 or more numbers. Another name for greatest common factor is the GCD, greatest common divisor. I've never heard it like that, but they call it that these days. So I don't know. I didn't learn that as a kid. If there's no common factors besides 1, then 1 is the GCF. So example, GCF of 7 and 10 would be 70 because I'm not 70. God, that's LCM. So example, GCF of 7 and 10 would be 1 because the factors of 7 is 1 and 7. Factors of 10 is 1, 10, 2, and 5. That's a 2. And so they only share 1 in common. That's an example. All right. So find the common factors of 12 and 15. Then find the greatest common factor between two numbers. As an example. So first we need to figure out the factors of 12 and 15. So let's list them out. Yeah, it should be 3, yeah. And you can see the common factor is 3. They also share, all integers share 1 as a common factor. But you see 3 is the greatest. But if you list all the factors, 12 and 15, we get this. Because 1 times 12 is 12, 2 times 6 is 12, and so on and so forth. 1 times 15 is 15, so on and so forth. 3 times 5 is 15. Then we compare the factors and see that 3 is the greatest common factor. So this is called the list method. That's how you learn, like start off learning, but we're gonna learn prime factorization, which is way better, way easier, way more fun, in my opinion. So here you go. So finding greatest common factor of 18 and 12 and the greatest common factor of 20 and 100. Why do you say 1,000, Jenny? I'm looking for the greatest common factor, not the. That's not even the least common multiple. Yep. Just because. Okay. All right, I'm gonna zoom this real fast. So if you didn't get a chance to type the right answer, don't worry. I'm sure you guys will know what happened. Okay. Factors of 18, 1, 2, 3, 6, 9, and 18. Factors of 12 are 1, 2, 3, 4, 6, and 12. So the greatest common factor between 18 and 12 is 6. Because they share 6, 6. So factors of 20 are 1, 2, 4, 5, 10, and 20. Factors of 100 are 1, 2, 4, 5, 20, 25, 50, and 100. And you can check 50 times 20 is 100, 25 times 4 is 100, 20 times 5 is 100. And so they share 2 in common, they share 4 in common, they share 5 in common, and they share 20 in common. And 20 is the biggest. So the greatest common factor between 20 and 100 is 20. Yeah. All right, multiples in LCM. So number A is a multiple of number B if A equals B times N, where N is an integer. So in other words, a multiple number is just that number multiplied by an integer. Example multiples of 5 would be 5, 10, 15, 20, 25, 30, 35, so on and so forth. Likewise, negative numbers are also multiples, but like I said, we usually don't. Yeah, I don't know. Ripsy, rest in peace. We usually don't list the negative numbers as multiples and or factors. And notice the number itself is also multiple because 5 times 1 is an integer. So watch out. So is 7 a multiple of 4? Well, obviously not, because 4 times anything Any integer will never equal 7. So no. What about 1? The multiples of 1 is just 1, obviously. I mean, not 1. No, multiples of 1 is not 1. Multiples of 1 is 1, 2, 3, 4, and keep going. But it's all integers. It's all the integers. All right, so common multiple, it's like a common factor between 2 or more numbers. It's a common multiple when they both share it, right? Can you include of 8? Every number is infinity. Yes, that's true, boy. Every number has infinite multiples. Can you include of 8? What do you mean by that? Like 1 is a positive. Okay. I'm going to continue on the lesson while you ask. So the least common multiple is the smallest positive integer that's a multiple of both a and b, where a is one number, b is the other number. So example, the LCM is 4 and 6. Well, the multiples of 4 is 4, 8, 12, 16, blah, 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 blah. And multiples of 6 are 6, 12, 18, 24, 30. So let's just multiplying it out. And the least, so they both share 36 and 12 as common multiples, but the least is 12. So the LCM of 4 and 6 is 12. Okay. Little practice. Find the LCM of 36 and 12. This one should be really obvious because 12 times 3. The LCM, Jenny. Oh, whoops. LCM, guys. We got a few more. We got a lot more slides to go. See, this is what happens when you get me distracted, talking about absolute zero and everything. Yeah, that's right, Max. Yeah. Oh, for number 2, yeah. That's right. Number 1, yeah. 2, you don't know? Well, we'll get there. All right, I'm gonna zoom through this. So if you list out the multiples, 36, 72, 108, and list out multiples of 12, 12, 24, 36, notice how they share 36 in common as multiples. So you get 36 as your LCM, least common, has to be least. You can keep going because this could be up to 72. They also share 72 as common multiples, but at least. 2 common factors of 3 and 2 and 1.5. 2 common factors of 3 is 2 and 1.5. No, because factors have to be integers. I think I said that, I don't know. And this one's 90, yeah. So no common multiples in this list. So keep going. We got 90 as common multiples. ICM or LCM? That is LCM. LCM, I see, yeah. LCM. All right, prime numbers, here you go. A prime number is a positive integer that is only divisible by 2 positive integers, one in itself. So in other words, a prime number only has 2 factors, one in itself. Okay, no other factors, integer factors, I should say. So which of these numbers are prime? Well, 10 is 5 times 2, so not that one. 12 has 6 times 2 and 3 times 4, not that one. 16, no, because that's 4 times 4, also has 8 times 2. And 17 is prime. What am I doing? 17 is prime. Yep, 2, 3, 17. Yep, 2, 3, and 17. Yep. Number that is not prime is called composite. It's called a composite number. It's a prime number. It's called composite. More in the next lesson. Prime factorization is a method we use when we want to express a number by its prime factors. I'm 99.9% sure you guys know how to do this. So you almost do like a tree branching method. The end goal is you reach all your prime factors, and can also be used to find the greatest common factor or the least common multiple. Least common multiple. So example, find the prime factors of 12 using prime factorization. Okay, so you got 12 right here, right? Can any even number other than 2 be prime? You think about that, Jenny. Think about that. Answer is, it's pretty obvious if you think about it. Okay, so you have 12. So let's start with, yeah. So how to prime factorize? Just start with 2 factors, right? So you have your number, start with 2 factors. That's not 1 in itself. So let's try 3 and 4. Now 3 is already prime, right? So we just leave it there. Now 4 is not prime. 4 has 2 more factors, right? It can also be further factorized, that's not a word, but can also be further broken down. Now 2 and 6 works too. You can try 2 and 6. And so 4 is also equal to 2 times 2. So, but 2 is also prime. So you're done with that. So prime factorization of 12 is 2 times 2 times 3, which is 4 times 3, which is 12. So it works out. Multiply it out, you know, 12. And see if you can try it with starting 6 and 2. So 6, 2. 2 is prime. I like to circle it when I'm done with the prime numbers so I don't get lost, but you don't have to. So yeah, you get the same result right here. All right, let's try with the GCF, greatest common factor. So let's try 18 and 12. So first you prime factorize those two. So let's do 3 and 6. You could do 9 and 2, and this one you could do 6 and 2. Yeah, you already know, but with prime factorization. So 3 is both prime. Then you further break this down, and these are all prime. 3 and 2 are both prime. So that's it. So next you look for common and prime factors. That is redundant. Cross it out. So 18 has 2 times 3 times 3, and 12 is 2 times 2 times 3. And what you do is you look for them common. So 2 times 3 is common, 2 times 3 is common, both found in there. 18 and 12 have 2 and 3 common prime factors. So this means the greatest common factor is going to be the products of the common prime factors, which means it's 6. So because 2 times 3 is 6, and they're both common. So that's basically how you do it. Yep. I know you already know. I know. I learned this in third grade too? 4th grade maybe? I don't know. If you did the list method, you would have gotten the same answer. And the method you choose, up to you. All right, least common multiple. So you just want to find out what's missing from 2 numbers. So when you prime factorize out 2 numbers, you just want to see which factors are missing and then pop them in. And you'll see what I mean later. So you find the LCM of 12 and 30. So you have 12 and 30. I'm going to zoom through this. So here are your prime numbers: 3 times 2 times 2, 3 times 5 times 2. Blah, blah, blah. You learned this in 1st grade. All right, good for you. I'm going to try to skip 4th grade. No comment. All right, so then you look at the prime factorization. And so if you look at 12's prime factorization, you notice that you're missing a 5. Sorry, I can't talk. You notice that you're missing a 5 here. So you just pop in the 5 because you have the 2 times 3 right here. And the 2 itself, this is already a part of its own thing, part of the 12. So you just pop in the 5. And so the least common multiple of 12 and 30 is 2 times 2 times 3 times 5 because you pop in the 5, which is 60. I was in private school, no question why. Okay. And you keep using the list method. You just list out the multiples. And the same thing looking at 30's prime factorization and see you're also missing a 2. So if you use 30's prime factorization, you have the 2 and 3 common. The 5 is its own thing. And just pop in the 2. All right. And we are almost done. Just do all these last questions. And once you get the answers, we're done. I had to rush through that because you guys want to talk about absolute zero and Gibbs free energy and the thermodynamics. You guys are crazy. Crazy, I tell you. Oh, you can skip number 1. Number 1 might be a little too long. Just do 2 to 5 so I know. Number 1, if it's too long for you, then you can skip it because class is almost done. Notice number 4 is not related to the lesson today whatsoever. Just a little mixed practice. It's not 5 inches. I'll tell you that. Good try though. Good try. It's not 5 inches. Number 5 is related to our lesson today. Yeah, that's true. What fraction though? You have to find the fraction. God, I need some water. My throat is dry. I see you, Mr. Kevin W. Instructor. I like that you changed your name. Very nice. Very nice. Do your work. Do your work. 37? Oh. Okay. Oh my god, Jenny's an admin, guys. Oh, watch out. Hopefully she doesn't abuse her powers, guys. Watch out. You guys are something else. You guys are something else. Number 5 is not 42 max. Maybe, did I word the question wrong? One piece is 36 inches long, the others is 48 inches long. He wants to cut them in equal pieces. So he wants to cut each string into equal pieces, like equal length pieces. That are as long as possible. At least I don't think it's 42. Let's see. Yeah, it's not 42. Yeah. You can ban me? Oh, don't ban me, please. Don't ban me. Please. Don't do it. Oh, you won't? Thank you, thank you. All right, well, it's 4 minutes past, so I'll just give you the answers now. If you have any questions, just stick by. I know I zoomed through this lesson because you guys want to talk about absolute zero and stuff. If you're teaching math, I don't know. Okay, I mean, maybe. Okay, so here's the answers. Let's see. So number 4, basically, you just find that 45% of Martin's class doesn't walk to school. So 55% does, 45% doesn't. And so you just find the fraction, 45 over 100, and simplifies to 920. So 9/20ths of Martin's class does not walk to school. Good, you don't know this? What? What? Okay, and these are the prime factors. Did I say common? Yeah, find the prime factors. Yeah, prime factors. Okay, so here are the prime factors. Technically 2 and 5, 2, 11, 13. I just like to write it this way. And notice how 81 only has 3, but it's 3 to the 4th. So you can also rewrite it as, and that would be perfectly valid because 3 is a prime number. So number 5 is essentially finding the greatest common factor between 36 inches and 48 inches because you have those 2 lengths of string and you want to cut them into equal sizes and you want to make them as long as possible. So you take the GCF, which is 12. So Zubin should cut the strings into 12 inches each. All right, that is it for today. This you can prime factorize. I recommend, highly recommend for these two that you prime factorize to find the solution to those two, because these 3 numbers are pretty big. And if you do this list method, it'd be a pain. So, yep. All right, you guys are free to go. If you have any questions, you can stick by. And don't talk about absolute value again. Not absolute value, absolute zero. Because what is E? Okay, that is a good, okay, that's a perfectly valid question. Okay, so what is E? So E is by a mathematician, noted by, no problem for everyone. I got you. Infinite. E is not infinite. E is, it's a number that, it's kind of like pi, where it has infinite digits, because pi is like 2.1419. I don't know the rest. 2.1419, and it keeps going. E is the same thing. So E is approximately 1 plus 1 over n, all in this in parentheses, to the nth power. And what is n? Now, what is n, you say, right? N is infinity, basically. So you just keep plugging in. I'm going to wait a second. What is n power? Okay, so what n means is that you keep plugging in integers, bigger and bigger integers for n, right? So technically, you actually write e as the limit as n goes to infinity over 1 plus 1 over n to the nth power. So n will continuously try to reach infinity, right? But there's no end in sight, okay? Because infinity, think of the biggest number in your head. There's always going to be a bigger number because that's the definition of infinity, right? That's infinite. You keep going. And so when you graph this out right here, you graph this equation as y equals, technically this function, 1 plus 1 over x to the x power, you will reach a line that looks like this, look like a flat line. And that flat line, it approaches this value called e. It is made by a mathematician called Euler. Euler is a very famous mathematician, very, very famous, very, very smart. Invented a lot of the things we use today. And so if you graph this out, you will approach, you won't touch it though. You'll approach it though. You'll approach it real close. You won't necessarily touch it. And this, I know this photo drawing that I made, it looks like it's touching it, but you'll get real close. That's the point of a limit. That's what this limit is right here, because it's a limit. It approaches it. So to approach the value of 2.71, blah, 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 I forgot the rest. What is x power? Well, if you plug in 1, right? X is just whatever you plug in for x on your coordinate plane. So remember the coordinate plane? So if that is the wrong button. If I had, what's good? Okay. So you have your function. You don't need to know what f of x is. Just bear with me here. 1 over x to the x power, right? You don't need to know what this is. Don't worry about that. And you have your, that should be straight. That should be straight. Let's try this again. So f of x equals 1 plus over x to the x power. Okay, there you go. That's better. So you have your y, you have your x, right? So there's 1, 2, 3, 4, and so on and so forth, right? The graph would look like this. If you graph this out, so if you plug in 1 for x, right? So that would be if x equals 1, this would be 1 plus 1 over 1 to the 1 power, which is 2, right? So 2 goes here. If you plug in 2, it would be 1.5 squared to the second power, right? Because 1 plus 1 over 2 to the x power, which is x is 2, to the second power. So that is like, what is that? 2.25, okay, so a little bit over 2. And you keep going. So 1 1/3 to the third power, that would be, I can't do that in my head. That would be 2.37, okay. I have a calculator with me. So 2.3, so a little bit over that. And you keep going infinitely, right? And then you will get a graph. If you graphed it out, you'll get a graph which looks like that. It won't reach 3. E is less than 3. I'll give you that. E is less than 3. Right. What is second power and y is equal to 2? That's small. Oh, you don't know exponents? Second power? Oh, you don't know exponents. Okay. Exponents is basically if you had x to the nth power, this would be multiply x by itself n times. What is 1 power? 1 power is just a number itself. So if you had 2 to the third power, 2 times 2 times 2. Because goes to the third power, you multiply by the base itself 3 times. 2 times 2 times 2. If you had 2 times 4th, it'd be 2 times 2 times 2 times 2. Now notice it's not the same as 2 times 4. This is tomorrow's lesson, exponents. But E, yes, the old meme, I forgot about that meme, that was the thing. E is this equation right here. And if you keep making x bigger and bigger, you'll eventually reach to about 2.7. I forgot the exact value, but you eventually reach 2.7 something. But you won't hit 3. Now, why is E important? Well, there's something called natural logs, ln, logarithms, log, there's E. Also, it's a pretty cool number. I mean, look at this equation. I mean, that's a pretty cool equation, right? But that is small. Yeah, it is small. Yeah, it is small. Although e to the nth power can get big really fast. Get big really, really fast. So if I were to show you, if I wanted to do y equals e to the x power, it gets big fast. It goes like that. That is y to the e to the x power. That thing goes big really fast for really, like, this is probably like, okay, so like this is 2.7. If this is e, erase that. So this is e right here, because this is 1. Obviously, e to the first power is e. And this is 2e, or e squared, 2. But then you go up here, like e to the 10th. That thing is huge. That is huge. It's really big. It goes, it's so e is actually, it is small by itself, but if you have exponential functions like this, thing is huge. That thing grows so fast. Once class ended a long time ago, you can go. People just had questions about e. And I know more about this than you guys do, so you can go. You can leave. So yeah, how do you do e to the 10th? Well, okay, e squared. E squared is that. And why does it grow so fast? Well, let's see. Well, if you had a calculator, you don't want to go for one? Okay. If you had a calculator, you can plug it in. Try e to the 7th, and it'd be a pretty big number if you had a calculator. You know what? I'll do it right now. E to the 7th is 1096.633158, right? How? Because it's 2.7 times 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 2.7. That's not even 2.7. That's the approximate value of E, right? It's approximately 2.7 to the 7th. 2.7 times itself 7 times, right? That gives you a pretty big number. In perspective, 2 to the 7th is 128. That's a big, the point, that's 1.28. What's going on? The 0.7 already made a huge difference, right? Because E is approximately 2.71, right? The 0.7, this 0.7 makes a huge difference. Look at the difference. 2 to the 7th is 128. So 2 times 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 2 is only 128. But then 2.7 times 2.7 times 2.7, 7 times is 1096. The 0.7 makes all that much difference. It grows super duper fast. So how does it grow fast? Because you're multiplying the big numbers together by a decently big number. E is, yes, it's small, but when you exponent it, when you put it to a power, that thing goes fast. It goes zoom speed. It goes sonic speed, dude. I don't even know if you guys know what sonic is. So yeah, any other questions? No? E is 2.7182818. Yeah. That's, yeah. There's more digits than that. There's more digits than that. But yes, that is the value of E. Now do that and multiply that by itself 7 times. So you multiply by, so multiply 2.71. So 7 times. 2.71 times 2.71 times 2.71 times 2.71 times 2.71, 7 times. So this is 5 times. Times 2.71 times 2.71. 1, 2, 3, 4, 5, 6, 7. 7 times. And that will give you a ridiculously large number. This is also equal to 2.71 7th power. 7th by. That's a 2. That's a 7. That's 1. That's a 7. 2.71 to the 7th power. And you'll learn about exponents tomorrow, don't worry. E7 squared. Okay. Let's see. That's not right, but yeah, you can leave. You can leave if you wonder. He's always asking me questions. So, that's not right. Where over 16? Yeah, you can leave. You can leave if you want. 19? Oh no, yeah, 19. Well, that's only equal to 19 because the e plus 1 is 10 to the first. That's only 19. Like I said, e starts off small. It goes big though. It goes really big. I don't know why you guys are still saying you can go. I mean, I find this interesting. This is cool, right? This is stuff I know. Pi times e is, that's not pi times e. You just keep copying e, Zoe. That's the value of e itself, just e. But pi times e is not that. Pi times e was probably more like 7 point something. Whoops. Pi times e. 8.539. Yeah. Approximately 8.539. So yeah, pi times e is, yeah, there you go. I mean, pi times e is not that big. 3 times 2 or 3 times 3 almost. Not that big. Try e to the pi power. Oh, I don't know if you can do that, but e to the pi power. What is second? What do you mean what is second? What do you mean by that? What is second? You mean like what is on the calculator it said? Like the second function? I don't know what calculator you're using, but talking about the second function, I would show you if my webcam was working, but obviously it's not. If you mean like the second function or something else. I don't know. I don't know what you mean the second, but you have any other questions, even about today's lesson or just about anything in general? E, Euler's number. Here, if you want to look it up. Euler's number. Z. E-U-L-E-R. That's a weird name, I know. It's pronounced Euler. Apostrophe S, space, N-U-M-B-E-R. Euler's number. All right, I think I'm gonna call it. I mean, it's fun. Not every day that I get to talk about Euler's number to people. Okay, I hope you guys have a good day, a good rest of your day or night, wherever you are. I will see you guys tomorrow. Yep, that is the value of E. All right. I'll end the meeting. See you guys.